Mars, our planetary neighbor, has captivated humanity for centuries.
From ancient mythology to modern science fiction, it has been a canvas for our wildest imaginations.
Now, as our robotic explorers traverse its surface, the red planet reveals its secrets.
Yet, with every revelation, new questions emerge.
What if Mars isn't as barren as we once thought?
What if forces, unknown, perhaps even alive, are hiding beneath its rust-colored crust? And, most importantly, as we edge closer to colonizing Mars, are we prepared for what we might destroy in the process? Today, we'll delve deep into the latest discoveries, the implications of colonization, and the ethical dilemmas shaping humanity's future on Mars. Strap in, because this journey is about to get surreal.
Mars has always been a tantalizing enigma.
Its blood-red hue made it a symbol of war in ancient civilizations, while astronomers like Percival Lowell sparked theories of Martian canals, proof, they claimed, of intelligent life. These ideas, though debunked, laid the foundation for our modern fascination.
Fast forward to the 21st century.
NASA, ESA, and other space agencies began sending robotic explorers to Mars. The missions, Spirit, Opportunity, Curiosity, Perseverance, were designed to answer one critical. In 2004, these twin rovers began rewriting Martian history.
They discovered evidence of water, ancient riverbeds and minerals that form in liquid water.
Mars, it turned out, wasn't always the dry desert we see today.
Then, in 2012, Curiosity took the stage.
Armed with advanced instruments, it confirmed the presence of organic molecules, potential building blocks of life. Suddenly, the idea of Martian life didn't seem so far-fetched. In 2021, Perseverance landed, carrying a new mission, to search for definitive signs of ancient microbial life. It even brought along Ingenuity, a helicopter that proved powered flight was possible on another planet.
Yet, with all these advances, something strange happened recently, something that has scientists scratching their heads. While exploring a rugged patch of terrain, the Curiosity rover encountered anomalies.
Initial theories ranged from gas emissions to magnetic disturbances.
But what if it's something more?
Could these patterns hint at an unknown force, perhaps even life, reacting to our presence?
When we talk about Martian life, we don't mean little green men.
We're talking extremophiles, microbes that thrive in extreme conditions. On Earth, such organisms exist in boiling hot springs, deep-sea vents, and even radioactive waste. If Mars hosts similar life forms beneath its surface, they could completely reshape our understanding of biology.
But here's where things get tricky. Suppose we find life on Mars. What then?
Do we have the right to interfere? Elon Musk's dream of a Martian city is inspiring. Starship rockets could transport thousands of people to build a self-sustaining colony.
However, colonization means altering the Martian environment.
If Mars harbors life, even microscopic, colonization could wipe it out.
The ethical implications are staggering.
Are we prepared to sacrifice an alien ecosystem for human expansion? Some argue for a cautious approach. Develop sterilization techniques to avoid contamination.
Design settlements that coexist with the Martian environment. Study native life, if it exists, before altering the planet. Others, like Musk, emphasize urgency.
If humanity is to survive long-term threats, climate change, nuclear war, asteroid impacts, we need a second home.
Mars is our best shot.
Some speculate that ancient Martian microbes adapted to underground refuges, where geothermal heat and subsurface water provide a sanctuary. Others propose even stranger ideas. Mars isn't just a planet, it's a mirror reflecting our hopes, fears, and responsibilities.
The debate over exploration versus preservation isn't new.
We faced similar questions when exploring Earth's own frontiers. The difference is, with Mars, the stakes are cosmic.
This isn't just about us.
It's about humanity's role in the universe. As we push forward, one thing is clear: space exploration is no longer just a scientific endeavor, it's a moral and philosophical journey. Mars challenges us to think beyond Earth's borders, to ask what kind of explorers we want to be. Will we be conquerors, reshaping planets to suit our needs? Or will we be stewards, learning to coexist with the universe's mysteries?
The red planet waits.
Its secrets, buried in dust and rock, promise to reshape our understanding of life itself. But as we reach for the stars, we must tread carefully, lest we lose something precious in our quest for discovery. Are we ready for Mars? Or, more importantly, is Mars ready for us?
This version should align well with your audience, sparking curiosity and engagement. Let me know if you'd like further tweaks or additional elements.
Breakdowns of rover technologies, including sensors, cameras, and communication systems. The challenges of remote exploration and the solutions engineered by NASA and other space agencies. Deep dives into the anomalies discovered by Curiosity. Hypotheses about geological, chemical, or biological explanations. Parallel examples from Earth's extremophiles and their ecosystems.
Philosophical arguments about humanity's responsibilities in space. The risks of contamination and its potential consequences.
Ethical dilemmas faced by earlier explorers on Earth. A more detailed exploration of Musk's plans for Mars colonization.
Technological hurdles and how SpaceX is overcoming them. Critics' views on the feasibility and ethics of Musk's vision.
Speculation about life beneath Mars's surface, microbial or complex. Theoretical impact on humanity's place in the cosmos if extraterrestrial life is confirmed.
How Mars exploration fits into the larger story of space exploration. Comparisons to the Moon, Europa, Enceladus, and exoplanets.
The philosophical implications of finding life, or not, on Mars. Encouraging public engagement with space exploration.
Highlighting the need for global collaboration in scientific discovery. I'll now expand the script step by step based on this outline. Mars has been a part of human imagination for millennia.
From its prominence in the night sky to its fiery hue, this planet has sparked wonder, fear, and countless questions. Ancient civilizations saw it as a god of war, a celestial body imbued with power and mystery.
Modern astronomers have long viewed it as a potential second home.
But what lies beneath its dusty surface?
This is a story of exploration, discovery, and dilemmas.
From the first telescope pointed toward the heavens to today's high-tech rovers, Mars challenges us to rethink everything we know about life and the universe.
And as we stand on the precipice of human colonization, we must ask, are we ready for Mars? Or will Mars redefine us?
The Babylonians were among the first to record Mars's movements, associating its reddish glow with the god of war, Nergal. The Greeks and Romans followed suit, naming it Ares and Mars, respectively. This association with conflict wasn't arbitrary. Mars's distinct motion in the night sky, moving erratically compared to other stars, made it seem alive, perhaps even sentient.
For centuries, humanity's understanding of Mars was limited to myth. But the invention of the telescope changed everything.
In the 17th century, Galileo Galilei observed Mars through his telescope, noting it as a spherical body rather than a point of light. By the late 1800s, Mars fever gripped the world. Astronomers like Giovanni Schiaparelli mapped canali on Mars's surface, misinterpreted as canals built by intelligent life. This sparked wild speculation that Mars was home to advanced civilizations. Even as better telescopes debunked these theories, Mars remained a symbol of possibility.
If not intelligent life, perhaps microbial life had once flourished there.
The dream of discovering life beyond Earth persisted, and the race to explore Mars began in earnest. The first attempts to reach Mars were fraught with failure. In 1960, the Soviet Union's Marsnik missions didn't make it past Earth's orbit. It wasn't until NASA's Mariner 4 in 1965 that we received the first close-up images of Mars. These grainy photos revealed a barren, cratered landscape, not the lush, water-rich planet many had imagined. As technology improved, so did our ability to explore Mars.
These twin rovers revolutionized our understanding of Mars.
Their discovery of hematite blueberries provided compelling evidence that liquid water once existed on the Martian surface.
This was a game-changer, as water is a key ingredient for life. Equipped with a sophisticated suite of instruments, Curiosity went beyond searching for water. It found organic molecules in Martian rocks, building blocks of life. While not proof of life itself, it showed that Mars once had the right conditions for life to emerge. Perseverance, the most advanced rover yet, is actively searching for signs of ancient microbial life.
Its companion, Ingenuity, has proven that powered flight is possible on another planet, a technological milestone that opens new possibilities for exploration. Each mission builds on the last, painting a picture of Mars as a world that was once dynamic and potentially habitable.
But with these discoveries come unsettling questions.
While exploring a seemingly unremarkable patch of terrain, Curiosity encountered something strange. Its sensors detected unexpected resistance beneath the soil, almost as if the ground was shifting in response to its movements. The rover's cameras captured peculiar patterns in the sand, symmetrical and deliberate, as if crafted by an unknown force. Initial theories ranged from gas emissions causing soil disturbances to magnetic forces interacting with Martian minerals. But could it be something more? If life exists on Mars today, it's likely microbial and buried deep beneath the surface, shielded from harsh radiation. On Earth, extremophiles, microorganisms thriving in boiling springs, deep-sea vents, and even Antarctic ice, show us that life can exist in conditions once thought uninhabitable. Mars may host similar life forms, surviving underground where liquid water might still flow. If true, this discovery would be earth-shattering, proving that life is not unique to our planet. SpaceX's Starship rockets aim to make Mars colonization a reality.
Musk envisions self-sustaining cities on Mars, where humans can thrive using local resources. This isn't just science fiction, it's a mission to ensure humanity's survival in the face of existential threats on Earth.
But colonization raises profound ethical questions. If Mars harbors even the simplest life, introducing Earth microbes could irreversibly alter its ecosystem. Terraforming, a process Musk advocates, would warm Mars's atmosphere, but at what cost? Could we unintentionally destroy native Martian life before even understanding it? Some scientists argue for a middle ground.
Establish stringent protocols to prevent contamination. Focus on studying Martian life before altering the environment. Develop technologies that allow us to coexist with Mars rather than dominate it. This debate isn't just about science, it's about our identity as explorers. Mars is more than a destination, it's a stepping stone.
Understanding its mysteries prepares us for exploring other worlds, from the icy moons of Jupiter and Saturn to exoplanets in distant star systems.
If life exists on Mars, it redefines our place in the universe. We would no longer be alone, and the possibility of life elsewhere, on Europa, Enceladus, or beyond, becomes even more plausible.
But if Mars is lifeless, it underscores the fragility of life on Earth, reminding us how precious and rare our existence might be. As we prepare to set foot on the red planet, let's ensure that our journey reflects the best of humanity, curiosity, ingenuity, and respect for the unknown.